Hey guys, so now we're going to do solving exponential equations. I'm just going to show you ones with the same base. All right, so I'm going to give you, those are some steps. I'm going to give you some steps like as we're doing it. Must have same. So the first thing we need to do, so the first one is going to be kind of hard, and we did one nearly similar to this in another video. But as we're doing this very first one, I'm going to be typing out the steps. If you're a step person, I'm a step person. Like, give me 4 or 5 things, file. I can do it every time. Right. So make sure they are same base. We are going to need a rewrite. And I'll come back. All right. So somehow we need, and there's going to be a clue most of the time, half and half. Okay. So the clue right now in this problem is there's a 5. And we need to somehow make this 625 5 to some power. Because one of the properties says that if you've got two bases that are the exact same, then the exponents equal each other. And so if we think to ourselves, well, 5 squared is 25. 5 times 5 times 5, which is 5 cubed, that's 125. 5 to the 4, so that's 5 times 5 times 5 times 5, that's 625. 5 to the x, 1 over 5 to the 4. All right, but I need them both on the same level playing field. I need them both on the top. And so in order to put that guy on the top, I'm going to make it a negative exponent because a negative exponent means move it, move it. And so he's really saying, hey, move me to the bottom. And then so that equals that. And so once they have the same base, we're going to have to rewrite it as needed. So one or both we're going to have to be rewritten. In this case, only one guy needed to be rewritten. After we do that, then we set the exponents equal to each other. Step 2 and step 3 is solve for x. All right, so here we left out because now we have x equals negative 4. We're done. Sometimes there'll be like a couple more to solve it. There'll be a couple steps, but in this case, there's not. So here's a good set of steps. Write them down or pause the video real quick. And write them down, and we'll do those same steps as we follow these problems. So here, I need to somehow make 81 have a base of 3. So I can think in my head, or I can go like 3 squared. Not good. 3 cubed, 27. 3 to the 4th, 81. So 81 is the same as 3 to the 4th, and then there's an x there. So I'm going to write that x equals 3. 3 is the same as 1. 3 to the first power. So now they have the same base. Since once they have the same base, you can just set the exponents equal to each other. So I have 4x equals 1. And then I'm going to divide by 4 because I need x to be all by itself. So we get 1/4. And if you want to check it, you can. So in your calculator, you could write 81 up 1/4, and we get 3. Notice 3 to the 4th is 81, and 81 to the 1/4 is 3. All right, let's do this one. So here we have a clue that we need 64 somehow to have a base of 4. So we could do in our head, or we can do 4 squared, 16, 4 cubed, 64. So I'm going to write 4 2x plus 1, 4 cubed. So now they have the same base. And when they have the same base, I can just look at the exponents. And so I have 2x plus 1 equals 3. And so I need to solve for x. So I'm going to subtract 1. So I get 2x equals 2. I'm going to divide by 2. And so I get x equals 1. Which makes sense. 2 times 1 is 2 plus 1 is 3. 4 to the third power, 64. Right here it's a little harder because we don't have a clue. Like if we did 27 squared, that's 729. It's not 81. And 81 squared is not, oh no, is not 27. And we can't use fractions. So we need to think of a number. It's normally tiny, by the way. We need to think of a number that will be 27 and 81. For example, 2, I don't know, to the third and 2 to the fourth. All right, well, 2 to the third is 8. 2 to the fourth is 16. So that's not 27 and 81. All right, but that's where we're going. So let's try 2 to the fifth. That's 32. It's too big now. So 2 to the fourth is 16 and is too small. 2 to the fifth is 32. It's not 27. So maybe let's try 3. 3 to the third. 3 squared is 9, so I know it's not going to work. 3 to the fourth. I don't know if we'll need 3 to the fifth. All right, 3 to the third. Awesome, 27. Maybe 3 to something is 81. 3 to the fourth. Oh, 81. 81. All right, so 27 is the same as 3 to the third, and then we have that x plus 2. Notice I put the x plus 2. 81 is the same as 3 to the fourth, and in parentheses I'm going to write that 1 minus. All right, this is as hard as it's going to get for these type of problems. All right, then I can cancel those. And now I have 3x plus 2 equals 4. And I need to solve it. And so to do that, I'm going to distribute. And so I get 3x plus 6 equals 4 minus 4x. I like my letters on the left, so I'm going to add 4x to both sides. I get 7x plus 6 equals 4. I'm going to subtract 6. I get 7x, 4 minus 6 is negative 2. Divide by 7. So I get x equals negative 2. Let's double check that. Seems kind of weird. Right, 3 to the third is 27, definitely. 3 to the fourth, 81, definitely. And we distribute. 7. Right, yeah, it's fine. Maybe you've seen something at home. Looks fine. Right, that's solving exponential equations. Do a couple of practice problems. I'll talk to you later.